Okay, now let's talk about these new pump charts. We'll work a couple examples and kind of get an idea how to use this new tool that we're going to have on our fire apparatus. What you see here is an example of one of the pump charts. It's not a specific one, engine 33. Start right out at the top, the crosslays. Crosslay number 1, crosslay number 2. We have those pump pressures printed right there for us. We have seen a range from about 115 up to anywhere upwards of 130 pounds. What that is it takes into account the friction loss behind the pump panel. Each rig is built a little different, and we're working on options to fix that, but for right now, we flow tested, and that's the pressure that's required on the crosslay discharge gauge to generate the 160 gallons per minute that the nozzle will produce. Again, that can be the fog tip or the 7/8 smoothbore. 50 pounds at the nozzle, that's the pressure required to get that pressure with the friction loss in the hose and that friction loss behind the engine panel. You also see front bumpers, 140, those are all going to be the same. They've been fairly consistent across the fleet. That takes into account that extra friction loss, the extra 90-degree bends, and the distance from the pump to the actual discharge where the hose attaches. So then the top half of the chart is the most straightforward portion. It's for our bulk load and the 2.5 static bed coming off the rear of the apparatus. You simply find the length of hose that's pulled, and it gives you the pump pressure, again for that discharge gauge, that you need to generate the appropriate gallons per minute with the nozzle. So for example, the bulk load, if I have a 300-foot bulk load pull, that's going to be all 1.75 inch. That hose is all green. I would pump that at 135 PSI on engine 33. Those have varied, most only about 5 pounds up or down. 2.5, same thing. Depending on the length, I find the pump pressure that I need on that discharge. To keep the chart simple, we only put every 100 feet. One of the things we have found is what if I've got a 250-foot 2.5 coming off that rear bumper? What do I pump? Well, the math says I would pump halfway between these two numbers, 87.5. Now, I don't know how accurate you are on the pump panel, but 87.5 is going to be tough. What we're teaching is to just round down. Pump it at 85. Pick a number in between the two. If it's an odd one, just round down a little bit. You'll have a much happier attack line crew. They're still going to be inside that 40 to 60 pound operating range for their smoothbore nozzles or for their fog either. And they'll have a much better experience. If they need more, if there are some issues with pressure, you can always move up another 5 pounds if that's appropriate. So that's kind of how the top half of this chart works. It's pretty straightforward. Again, if I'm at 350, between 135 and 140, I would just pump it at 135, and if there's an issue, I could cheat it up another 5 pounds. The additional lines, the bottom half of the pump chart, is where we can make up any combination that we're presented with on the fire ground. One of the challenges we've already talked about before is when we kind of set this up, if all of the hose beds were the nice newer, or that newer wide 72-inch hose beds, we could cheat and have 2 bulk loads coming off the back. We didn't have enough real estate for that. So we were only able to put 1 bulk load on the rear step. So where this comes into play is when there's a second line. So we'll work a couple of examples to see how to use this bottom half of the pump chart. It gives us the friction loss for 100 foot of hose, each of the sizes of hose that we now carry on the engines. Green, or the 1.75 inch coming off the back, those bulk loads. 2.5, all of the 2.5 will be blue, either 160 gallons a minute if it's supplying an 1.75 inch line, or 300 gallons a minute if it's supplying a 2.5 inch nozzle. And then we have our supply lines, our 3 inch and 5 inch, for various other hand lines and supply situations. So let's look at a couple of examples, and we'll talk about how we can get there. So the first example we're going to look at is the first line has been deployed, and it's a 300-foot bulk load. So I can come here and see that that pump operator is going to be pumping 135 psi for that first line. So now the question comes the second line. So let's see what it looks like in picture form here. So we have our engine, engine 33 is here, and they have their bulk load deployed at 300 feet. Well, we know that that's going to be all 1 3/4 hose. So that is the 300-foot initial line that they deployed off of their bulk bed. Now you come up and you're on the second due engine. You're tasked with stretching an additional line and you choose to come off the rear. Let's say that you've put your line together, and we'll just write it out here first. And so your 300-foot line is going to be the second line. You've pulled the Minuteman bundle off of your bulk load, off of your engine, and brought it to the fire scene, that 100 foot of hose line. So this one is going to be that 100 feet, 1 3/4 Minuteman that you brought from your engine, and 200 feet of the 2.5-inch static bed, either from the bulk side, that's the rest of the bulk load. That's the other 200 feet of 2.5 under there. So that's a quick, easy grab. It's not taking away any capabilities. So what that looks like over here on our graphic interpretation of this is on the other rear outlet, I have 200 foot of 2.5 with the bell reducer and 100 feet of 1 3/4 to finish it out. Now I have my second 300-foot line, and again, this is 160 gallons a minute because I have that 1.5-inch nozzle on the end of the hose. So what does that look like for my pump discharge pressure? Very similar to an old thumb rule. We have right here the nozzle pressure. So think 50 plus. So I have 50 plus I got to add the friction loss in the hose. Again, 160 gallons a minute, work back from the nozzle. I have 100 foot at 160 gallons a minute of green 1 3/4. So 1 3/4, 160 gallons a minute, 25 per 100. So I got to add 25 here. And then I'm supplying it with the last piece. 200 feet of 2.5 at 160 gallons a minute, so I'm here. So that's 5 per 100, so there's 2. So 2 5s. So that's 10. So 50 plus 25 plus this 10. 75 plus 10 or 85 total. So for the second line, I need 85 psi. Now again, it's much lower than the first line because there's much less friction loss in this first piece. Okay, so we've added that extra bit of friction loss for the 2.5. Now let's look at a second example. We pull up and there's a 400-foot bulk load been deployed. Okay, again, that first line, 400-foot bulk load, he's going to pump 140. Straight off the chart. Again, now what that looks like, you have 100 foot of 2.5 with 300 foot of 1 3/4. Bell reducer. Again, 160 gallons a minute. So that's 300 and 100. So now I don't have as much 2.5 left in the bed. So we choose to deploy a 100-foot 1 3/4 that we brought with us from our bulk load, and we're going to have a 300-foot 2.5 to feed it. We can pull straight from the 2.5. It has the nozzle. We can remove the tip and attach that 1 3/4 right to it. So now the second line looks like this, where it's 300 foot of 2.5, 100 foot of 1.75 inch. Same sort of flow rates, same rules apply here. So I had 50 for my nozzle. Again, it does not matter which nozzle tip. I have now 3 and 1. Let's start at the nozzle. We have 50 for the nozzle. The friction loss in 100 foot of 1.75 inch is 25. We have 3 sections of 2.5, so 3 5s is 15. So 50 plus 25, 75, 85, 90. And this is again for our second line. What you'll start to see is there's trends will start to develop as there's different ways to put this together. And you'll start to recognize some of the options. Depends on where this 1.75 inch comes from. You could pull a pre-connect and attach it to 200 feet of 2.5. Again, the way to put it together is here. One other thing we'll look at, where we use another part of the bottom of the chart, is what about extending a 2.5? So let's say that we have a 300 foot 2.5 that's been deployed. So the first line is a 300 foot 2.5 inch hose line. Okay, from the chart, 300 foot 2.5 is going to be at 95 psi. The other thing we're starting to see is these pump pressures are all getting lower. The highest pump pressure we're really seeing is the longest bulk load, 145. So that's an advantage to, again, another one of the advantages to this system is some lower pump pressures because we lowered that nozzle pressure. So I have this, I only have another 100 foot of 2.5 in the bed. Again, I can bring my 100 foot Minuteman nozzle bundle from my engine, or I can put this together on the fire scene. The bundles for the standpipe operations that are located in the compartment are also available. So let's say we have used 200 feet of the 2.5 that's bundled in that apparatus. It already has the nozzle on it. And I've had to extend it with 100 foot of 3 inch to get my 300 foot length. So I have 100 feet of 3 inch hose. And I've extended that with the 200 feet of 2.5, and again, now 300 gallons a minute. So we start at the nozzle, 50 psi for the nozzle pressure. Same nozzle pressure, doesn't matter what size handline it is. 200 feet of 2.5 at 300 gallons a minute, so I'm here. 300 gallons a minute, 200 feet, so that's 2 15s, 2 times 15, or 30, plus 100 foot of 3 inch at 300 gallons a minute, that's about 10 psi. So I've got 50 plus 30 plus 10 is going to be 90 psi, again, for the second line. So same line, flow rates, different hose configurations, we may see different pressures. It's nothing that can't be figured out quickly on the fire scene, noted on your pump panel, noted on your discharge gauge, however you choose to do that personally. These are just a few examples of how to use these lines. We went ahead and put the friction loss numbers for the 500 GPM on the 3 inch and the 1000 GPM on the 5 inch. There was room, and it fills out the complement so that as things start to get complicated on the fire scene, it's captured there for you to try to get the easy math. Again, this is sort of that target flow rate for the RAM. The 20 psi has been around for a long time and will continue to be. So when you have questions about this, please reach out to somebody from the committee. Dan Lohman is probably the best resource, but we're all available. So if anyone has any questions, please reach out. Thank you for your time, and look forward to seeing everyone in the future.